we have the mass of the car, horizontal, constant speed, no acceleration. We have the velocity. We have the resistance force. Find the power of the engine in kilowatts. So first of all, constant speed means no acceleration, so we use sigma f equals 0. We have only two forces in the horizontal direction, the engine force and the resistance force. So since we have sigma f equals 0 here, the net force should be 0. The engine force is therefore equal to resistance force. And to find the engine power, we use engine force times velocity. So in kilowatts, this is the answer. At least use 3SF. Now for the second part. Now moves down a hill. Angle theta, we know the sine theta, and we know the engine power, the velocity, and 10 seconds later we have time, we have distance down the slope, and we have final velocity. So we have the mass, and we have the engine power, we have the time, which means from here we can find the engine the work done by the engine. And we also have the resistance. We are finding the resistance work done by the resistance force. And if this diagonal distance is 280, using sine here, sine theta is h over d, h is d sine. So we use 25.2 for the vertical distance traveled. Initial speed, final speed. So because of the resistance force here, just think of friction. Because of friction, the object will be warmer in the end. So we're gonna say we have thermal energy in the end. Now we use energy conservation. Energy lost equals energy gained. Energy lost, because it's going down the hill, we have potential energy. And because we have engine force, engine power here, we have work done by the engine, so we are losing chemical potential energy in the fuel, and we are gaining, the speed is increasing from 24 to 32. We have gain in kinetic energy, and we always have thermal energy because of the resistance force. This is the work done by the resistance force. This is what we are looking for. So for the work done by the engine, we know the power and the time, so this is the formula we use. For potential energy, mgh, 1/2 mv squared, so we subtract 1/2 mv squared from both sides, and then we plug in the numbers. This is the power, time, the mgh, and 1/2 m delta v squared. Remember, this term should be positive, so 32 minus 24, not the other way around. Square first and then subtract, not the other way around. And use a calculator, we get the final answer. All right, I'll see you